Good morning. Today we are going to learn how to differentiate between Gaviscon and antacid. First of all, we are going to determine the equation for the reaction between magnesium hydroxide and hydrochloric acid. Secondly, we will calculate the moles of hydrochloric acid.
The full equation of magnesium hydroxide MgOH2 with hydrochloric acid HCl is equal to MgOH2 plus 2HCl will produce MgCl2 plus H2O. So now the question here is how many moles of hydrochloric acid are neutralized by the 2 tablets of magnesium hydroxide. First of all, to calculate the moles of hydrochloric acid HCl, we must know how much magnesium hydroxide MgOH2 in 2 tablets, since the label suggests a dose of 2 tablets. 1 tablet contains 250 mg of magnesium hydroxide. This means that 2 tablets contain 500 mg of magnesium hydroxide. Thus, 2 tablets contain 0.5 g of magnesium hydroxide. Next, we need to calculate the molar mass of magnesium hydroxide MgOH2. 24.305 g per mole plus with 2 times total of 15.999 plus 1.008 g per mole. This is equal to 58.319 g per mole. This means that the molar mass of magnesium hydroxide is equal to 58.319 g per mole. Then, the number of moles of magnesium hydroxide MgOH2 is equal to 0.5 g divided with 58.319 g per mole. This is equal to 8.574 times 10 to the negative 3 mole. This means that the number of mole of magnesium hydroxide is equal to 8.574 times 10 to the negative 3 mole. So now, we know that from the equation, 1 mole of magnesium hydroxide MgOH2 will neutralize 2 mole of hydrochloric acid HCl. So, 2 tablets times with 8.574 times with 10 to the negative 3. This is equal to 0.0171 mole. This means that 2 tablets of magnesium hydroxide MgOH2 will neutralize 0.0171 mole of hydrochloric acid HCl.
Besides that, we are going to learn about Gaviscon. Gaviscon and antacid undergo the neutralization process to cure heartburn.
The general equation shows that alkaline reacts with acid will produce salt and water.
But that is not the uniqueness of Gaviscon. The uniqueness of Gaviscon is it will produce rough.
The main ingredients of Gaviscon are sodium alginate, sodium bicarbonate, calcium carbonate. Now, I will talk about the mechanism of Gaviscon. First, soluble sodium alginate reacts with stomach acid to form insoluble alginic acid, a linear polymer. Next, calcium carbonate dissolves in the stomach contents, releasing calcium ions Ca2+. Third, this linear polymer is cross-linked by calcium ions, originally formed the calcium carbonate to form an alginate rough. Next, the sodium bicarbonate and calcium carbonate react with a little of stomach acid, forming carbon dioxide gas. Then, the carbon dioxide will lifting the rough so that it floats on top of the stomach contents. This will preventing the reflux into the esophagus.
For a better understanding, let us watch a video regarding the mechanism of Gaviscon.
Gaviscon double action is an alginate antacid combination, licensed for the treatment of symptoms of gastroesophageal reflux, such as acid regurgitation, heartburn, and indigestion. Upon ingestion, the high-grade alginate in Gaviscon double action reacts with gastric acid to form a low-density viscous gel. The calcium carbonate within the formulation neutralizes gastric acid to provide fast relief from indigestion and heartburn. It also releases calcium ions that bind within the alginate to strengthen the gel. The antacid effect of calcium carbonate is increased by sodium bicarbonate. In addition, the bicarbonate reacts with the gastric acid to produce carbon dioxide. The carbon dioxide bubbles become entrapped within this low-density gel to form a buoyant raft. This now buoyant raft floats to the top of the stomach, creating a physical barrier that helps prevent reflux of stomach contents into the esophagus. Gaviscon double action's high-grade alginate has now strengthened into a long-lasting barrier to reflux that can reside in the stomach for up to 4 hours.
Apart from that, we are going to learn about the mechanism of antacid.
Antacid contains alkaline ions OH negative to neutralize the stomach acid, which is hydrochloric acid HCl. Example of antacid is mole of magnesia, MgOH2. Neutralization is happen between MgOH2 plus 2HCl that will produce MgCl2 plus H2O. The difference between Gaviscon and antacid is that Gaviscon can neutralize and produce a raft, but antacid can neutralize only.
I think that a lot of customers don't know which one is better. Is it Gaviscon or antacid?
Of course, it will be Gaviscon.
There is an investigation. It investigating the number of acid reflux episodes reduced. Investigation shows that antacid is 15 versus Gaviscon is 3.5. It also investigating the time for acid reflux to increase. The investigation shows that antacid takes 14 minutes, while Gaviscon takes 63 minutes. Long-term effect of antacid is that it causes malabsorption of nutrients because of the pH environment of stomach. There is difference in pH changes by mole of magnesia and Gaviscon liquid. Mole of magnesia will change pH of 3.3 to pH 9.8, while Gaviscon liquid will change pH 3.3 to pH 7.3.
With all the proof given, therefore, we can conclude that Gaviscon is better than antacid.
Oh, I see. Thank you for your explanation.
That's all for this talk. Thanks for your participation.